Good afternoon. I'm Paul Feldstein. I'm the CEO of Circularis, where we're helping our customers improve their protein production. Cells are factories that make protein. Those proteins are found everywhere, from our laundry detergent, the medicines we take, even in the food we eat. Currently, the protein economy is worth over $350 billion a year, and it's growing. That's huge. So, if cells are factories, promoters are the factory foremen. Here you can see the red factory foreman controlling the cell's protein-making machinery to produce this amount of this red protein. So let's say we want to make a different protein, a valuable protein, like this green protein. The question is, which factory foreman should we give the job? With our technology, we can essentially interview all the factory foremen in the cell and ask the question, which one is best? There are actually thousands of factory foremen present. In this case, it's our yellow factory foreman who's making the most protein. So let's give him the job. The problem is, what if he only makes this amount of protein? This is the amount of protein he's used to making. What if that's not enough? What can we do about it? We can make him better using our technology. We can actually allow him to produce more protein, and that's important because that's more valuable. Another application of our technology is in pathway optimization. In this case, there are multiple steps between the starting material and our desired product. Sometimes there are actually branches that essentially steal material out of our pathway from starting material to desired product to make some other product. Using our ability to optimize promoters, we can actually improve the amount of the proteins that we want to essentially increase the amount of starting material converted to desired product while reducing the amount of side product produced to either very low or essentially zero. So the Circularis solution is to find better promoters. We can do it quickly. We can do it comprehensively by essentially looking at millions of variant promoters at once to find the best ones. We can also do it in any organism and any cell type. And we've actually done this. This is an expression of a very commonly used protein called the green fluorescent protein. What I'd like you to do is concentrate on what's in this red oval. Okay, if you look at the purple band at the top, you'll notice that it's a lot more intense than the purple band at the far left. That purple band is how much protein is made by the natural promoter. This is what's known as the T7 promoter. It's a very commonly used promoter. It's been used for over 30 years in E. coli for protein production. And you can actually see that our cells are making more protein because you can see the increased glow. In little more than 2 weeks, we were able to find a better promoter that produces between 2 and 3 times more protein than the natural promoter. So we've already deployed our bacterial system. We've shown that our system works in animal cells. By the end of the year, we expect to have proof of concept experiments in fungal and plant cells, and we'll begin marketing our systems to potential customers. We actually already have deals in the works with Zymergen and Evolva. So we have a lean business model. We're going to start where we are, which is improving protein production. It's a simple process where we'll adjust the strength of the promoter to produce the maximum amount of protein. Next, we're going to move on to platform optimization. That's that process where we have multiple steps where we'll increase or decrease the strength of promoters to maximize the amount of starting material converted to product. At the same time, we're going to be using our technology to develop new protein and chemical production platforms. Ultimately, we're going to use the revenue from those first 3 steps to develop our own products using our own promoters, our own platforms, and the information that we've developed to make our own products our own high-value products more efficiently than anyone else. So we only have one direct competitor, Synpromics out of the UK. Our technology is superior. We can directly find promoters. We can optimize promoters with 10 to 100 times more variance in one step than they can. And once we find the promoters, we can examine different conditions in which they're active in one step. Because we have a superior technology, we've had strong interest from these companies that we've talked to. Each of these companies has wanted to do a project with us, which is a little overwhelming, but is also so cool because people want to use our technology. We can address roughly $215 billion worth of markets, predominantly a $100 billion market in biologics, where protein production is very important, and another $100 billion market in animal, plant, and microbial platforms optimization. Our scientific team consists of myself. I'm a nucleic acid biochemist. My co-founder is Leanne Lindsay, who's our chief animal cell scientist, and Jim Lincoln, who is our chief plant and fungal scientist. Our advisory boards include people with experience in protein production, startups, and in business development. Our intellectual property is secure. We have 2 provisional patents filed last year that cover our core technologies. We're currently raising $1.5 million in seed funding, which will allow us to build the teams necessary to fully deploy our platforms. If you're interested, please come and see us afterwards and come and see our glowing bacteria. Thank you.